Welcome to Day 4, 6.4, 6.5, Rational Exponents and Radicals. So today we're going to simplify some radicals, and we're going to essentially switch to exponential form. All right, so we're going to simplify these 5 examples here. We're going to leave no negative exponents or decimal exponents in our final answers, and we're going to leave final answers in exponential form, not radical form. Okay, so one kind of key takeaway is in order to simplify, we either need common bases or the same index. Okay, so same base or index in order to combine and multiply divide these radicals. Okay, so let's go ahead and dive into this first example. The square root of 6 divided by the square root of 2. First, let's go ahead and switch to exponential form. So the square root of 6, we should get 6 to the 1/2. And we're going to divide by 2 to the 1/2. Okay, so now remember, I said in order to combine these, we either need the same base or the same exponent, right? Well, what we should notice is our exponent is the same, right? So we can rewrite this. This is going to be the same as saying 6 divided by 2 raised to the 1/2. Okay, so we work inside those parentheses first, and we're going to get 6 divided by 2 is going to be 3 raised to the 1/2. And this is as good as we're going to get. So here is our final answer. Let's take a look at this example 2. The square root of 8 divided by the 4th root of 32. So the first thing we'll do is we will rewrite these in exponential form. So the square root of 8 we should get as 8 to the 1/2 divided by the 4th root of 32 is like saying 32 to the 1/4. Now notice our exponents are different, as are our bases. So since our exponents are different, our powers here are different, let's see if we can get common bases. So I can't rewrite 32 to be 8 to some power, right? So we need to make each of these bases different. So what's the common base between 8 and 32? Well, hopefully you recognize we can rewrite 8, so it's going to be 2 cubed. So we'll call this 2 cubed to the 1/2 power over, how can we rewrite 32? Well, hopefully you recognize 32 is 2 to the 5th power, and we're going to raise that to the 1/4. Okay? So now what do we do here? Power of a power. Hopefully you remember, we're going to multiply these. So what we really get is we're going to get 2 to the 3/2 power divided by 2 to the 5/4 power. Now our bases are the same. So when our bases are the same and we are dividing, what do we do to our powers? So hopefully we remember we're going to subtract. So I'm going to bring this work over here. And what we can really think about is, all right, well, this is like saying 2 to the 3/2 minus 5/4. Okay? So we need common denominators because we're subtracting fractions, right? So 3/2 minus 5/4, well, we can rewrite 3/2. 3/2 is like saying 6/4. And now we can subtract. So we're going to get 2 to the 1/4 power, and there is our final answer. I want you to try this third example on your own. This time we're going to be multiplying, so you have to think about what you're going to be doing. I want you to rewrite it in exponential form. So the cube root of 128, what does that become? And the square root of 32, what does that become? All right? Remember, in order to multiply, we either need the same base or we need the same index, which we don't have here. So see what you need to do. Come back and check when you're done. All right, how'd you do? So hopefully the first step you rewrote into exponential form. 128 to the 1/3 times 32 to the 1/2. We can't multiply these because, one, they're not the same base with the same exponent or with the same power there, okay? So the index here is different. Those powers are different. So we need those common bases. So we have 2 to the 7th is how we'll rewrite 128. And 32 is 2 to the 5th. Power of a power, we multiply those powers, okay? So now that we have the same base, we can go ahead and combine those powers by adding them. We'll need common denominators since we have fractions, so we get our final answer here of 2 to the 29/6. Looking at this next example, how do you think we're going to approach? Well, hopefully you recognize that, hey, these guys are both underneath that big radical, and they have the same base of 2. So why don't we work inside first, all right? And then we'll worry about that cube root. So at the same time, we could go ahead and rewrite this as 2 to the 3.1 divided by 2 to the 0.7, all raised to the 1/3. So we'll do kind of 2 steps in one here, just rewriting. Now that we have the same base of 2, we can go ahead and subtract our powers. So 3.1 minus 0.7, inside we will get 2 to the 2.4 power, right? 3.1 minus 0.7, and this is all raised to the 1/3 power. Power of a power, what do? We're going to multiply. So 2.4 times 1/3. That's going to get us to 2 to the 0.8 power. But our directions at the beginning said no decimal exponents. So we need to rewrite this 0.8, and we can think about it as 8/10, right? If we read that correctly. So this is like saying 2 to the 8/10, but we would want to simplify that, of course. So really we have 2 to the 4/5 power, and there is our final answer. I want you to try this next example here, the 4th root of the cube root of 16. So here's my little hint, work the inside out, all right? See what you can get, and see if you can simplify it completely. Give it a try. Okay, so how many people stopped here? 16 to the 1/12, right? So let's just see. So the cube root of 16 is like saying 16 to the 1/3. The 4th root of that whole thing is like saying 16 to the 1/3 to the 1/4. Power of power, we multiply. 1 times 1 is 1. 3 times 4 is 12. However, 16 is not the smallest base you can rewrite or have, right? So what's the smallest base we can have? Well, 16 can be rewritten as what to the what power? Well, hopefully you recognize that that's like saying 2 to the 4th power, okay? So 2 is the smallest base. Now, power of a power, we can multiply. 4 times 1 divided by 12, we should end up with 2 to the 1/3 power. 4 divided by 12, there lies our final answer. So if you stopped at 16 to the 1/12, you always have to ask yourself, is 16 the smallest base, or can we rewrite it as a smaller base raised to some power? Next, we're going to get into solving exponential equations. And in this section, our first goal is to get common bases, okay? Get common bases. Later on, we'll talk about, well, what do we do if we can't get common bases, all right? So Typically, if we were in class, I would hand you a piece of paper and I would ask you to take that piece of paper and see if you can make it bigger. And you would look at this piece of paper and say, I can't make that bigger. But if you take that piece of paper and you make it smaller, you could fold it into smaller pieces, right? And not change the fact that you have one piece of paper in your hands. And that kind of goes the same way with our bases. I can't take a piece of paper and make it bigger, but I can take a piece of paper and make it smaller by folding it. All right? I'm keeping that same value. With our bases, I can't take a base and make it bigger. I can take a base and rewrite it as a smaller base raised to some power by not changing the actual value. So let's look at these examples here. 64 to the x equals 4. Our goal is to get common bases. I notice 4 is the smaller of the two bases, 64 versus 4. My first goal would be to take 64 and rewrite it as 4 to some power. If I can do that, I'm going to. If I can't, that means I probably need to change both bases. But the good news is we can take 64 and we can rewrite that as 4 cubed equals 4. Now, I could say 4 to the first power, right, just to kind of make sure we've got that. Now, notice 4 cubed is still 64. I did not change the value, okay? I just rewrote 64. So now we take that left side and we have our power of a power, so we're going to multiply that. So we can rewrite this as 4 to the 3x equals 4 to the first power. Now that the bases are the same, what do you think we have to do? Or what do you think also has to be true? Well, since the bases are the same, we can zoom in on these exponents, on these powers, and set those equal. So I'm just zooming in and I'm saying, well, that means 3x has to equal 1, and we can solve and get x equals 1/3. And there is our answer. Now let's take a look at this next example. 49 to the x equals 343. So I compare the bases, 49 and 343. Is there any way we could rewrite 343 so it's 49 to some power? Well, 49 squared certainly isn't 343. So what does that mean? It means we need to take both bases and rewrite them as a smaller base raised to some power. So you have to ask yourself, well, what's the common base between 49 and 343? Well, hopefully you recognize 49 is like saying 7 squared to the x power. And hopefully you recognize 343 is like saying 7 cubed. All right, so now that left side, we're just going to rewrite it as our power of a power. So we're going to multiply those. So we're going to get 7 to the 2x equals 7 to the third power. Now we have common bases. So we can go ahead and zoom in on those exponents. 2x has to equal 3. And we can solve this from here, getting x is equal to 3/2 as our final answer. Finally, let's take a look at this last example. 625 to the x equals 1. Well, we have to ask ourselves, are we ever going to get common bases between 625 and 1? Can we rewrite 625 as 1 to some power? No. So what does x have to be? When we take something and we raise it to the x power, and in the end we get 1, hopefully you recognize what x has to be. X has to be, drum roll please, 0 in order for that to work. All right, if you have any questions on this, let us know. Have a good day.